1, but I think it's S sub B1 or whatever. Plus or minus T sub alpha over 2 times S sub E over the sum of X minus X. Okay? So that's pretty simple. Basically, let's pull up our worksheet from yesterday. Assignments, we'll just do what we did yesterday. Class worksheets, 14.1 worked out. Trying to remember. Okay, I think this page has everything that we need. Okay. So if we look at this, basically I need my M. M in this case is, well, that's not on this page. That's from the scatter plot, which is 1.3991, right? So 1.3991. I need my T sub alpha over 2. And do you guys know how to pull this up on the computer without this table? How do you do it? T dot inverse. We're going to do the inverse two-tailed. Okay. Your probability is, in this case, 0.05. We're doing a 95% confidence interval. Degrees of freedom in this case is, I don't know. I'm going to guess 12, but I can't remember if that's right. This is 14, I guess right, 12. Okay. You could also look that up on the table. If we were looking up here, 12 degrees of freedom. So I'm going to look at the 0.025 column because it's two-tailed, right? Confidence intervals are always two-tailed. So 2.5% in each one. 12 degrees of freedom gives me 2.179. So either one. Obviously the computer's a little bit more accurate. Okay? Then I'm going to need the S of E, which is that value right there. And I'm going to need the S of M. Oops. S of M, which in this case is, no. I need the sum of the, sorry, I'm just looking on. I need the sum of the xi minus x bar. Somebody in my other class said, isn't SE divided by that sum S of M? And I said, yeah, but this is the formula they give you, so I'm just trying to follow it. Okay? So that's going to be simply this sum right here. Okay? So if I do my lower and my upper, I'm going to do my M minus my T sub alpha over 2 times my S sub E divided by the square roots of that sum. Okay? And so I will copy that and paste it, and I will change that minus to a plus.
I have a question.
Yes.
It'll be the sum not squared, right?
Well, these are already squared here,
Right,
so you
but
sum
it's-
them.
But it's SE over the square root of that. So wouldn't
SE
it
over
be-
the square, oh yeah, I guess, just do it that way.
Okay.
Get the sum, square it, and then square
Wait,
root.
so the x minus xi is the x.
Because I have a feeling, I know what you're saying, because you're trying to save a step, and I would just not worry about that. So if you do the square root of this, does that equal the sum of this? Oh, I don't have that column. Well, I could make one really quick. Equals xi. Well, the problem is, yeah, these are going to be negative. Sorry, it's going to be xi xi minus x bar. Yeah, that's gonna be a problem. Sorry, that should be down one. Because see how these are negative? And then when I add those up, I got a very different answer.
Well,
So
that's why you square it first, right, to make sure.
square it
it's-
first and then square root it, yes.
Yeah.
So you don't have that problem. Okay?
Can you highlight your lower calculation?
Where's that? Highlight my lower.
Yeah.
Basically,
I'll
it's
just square
those
root.
four numbers.
Okay.
Yeah. Okay? So Ryan wants to interpret this confidence interval for me. You can tell by the look on your face.
Yeah, so we can say with 95% confidence that, what are we testing? Or
That is, the
what is
slope.
the, between
So he was spacing out.
4 and 3.
So what's between there? Whatever we're testing?
The slope?
It's the slope, right? Slope is between there. Is your slope significant? Can you tell that from the confidence interval?
Isn't significant because 0 is not.
Because 0 is not. Now, one of the things that just occurred to me, when we're interpreting confidence intervals, I did notice this. I don't think I brought it up. Well, I guess because I finished it over the Thanksgiving break. A lot of people were looking at confidence intervals and they were only looking for if 0 was in there. So there was a 0. So there was a confidence interval that said 9% of something was happening, and people were saying, "Oh, it's significant because 0 is not in there." In that case, no, you were trying to compare it versus the 9%. So you got to be a little bit careful about that. On these later ones, yeah, we're looking for 0. On the earlier ones, we may not have been. So you'll probably want to review that again. Okay? All right. So anyway, that's the end of 14.1. It's time for 14.2. Okay? So 14.2 also deals with confidence and prediction intervals. Okay? So, kind of along the same lines, but we're no longer worrying about slope. Okay, so let's talk a little bit about the confidence interval for, confidence interval of y for y hat. Okay? So it's basically y hat plus or minus t sub alpha over 2 times your s sub e times the square root of 1 over n plus x star minus x bar squared over the sum of xi minus x bar squared. Okay? Where x star is a given value with degrees of freedom equal to n minus 2. Okay, not to be confused with the prediction interval. I'm going to give you both of these formulas. Okay. Prediction interval is y hat plus or minus t sub alpha over 2 times s sub e times the square root of 1 plus 1 over n plus x star minus x bar squared over the sum of xi minus x bar squared. Okay? Once again, where x star is a given value, and your degrees of freedom also equals n minus 2. So one of the things you're going to notice is the only difference between these two formulas is this one has an extra 1 in it. This one does not. Otherwise, they're exactly the same. Okay? So let's talk about why and how you would do this. So since we already have this spreadsheet open, okay, let's say, let's go back to here for a second. Okay, so one of the things we were trying to say, I really should have done this way better. Okay, this was age, this was cholesterol. Okay? So one of the things that we discovered with this is the same example we did yesterday, was it appears that as you get older, your cholesterol just naturally goes up, right? So we can see that the ages here are from 25 to 65. Okay, I'll make that a little bit bigger. I know that's a little bit hard to see. So the question is, let's say, you know, you're in the middle. You're, let's just say 42 years old. Okay? So you're a little bit worried. Now, let's look at this. We actually do have a 42-year-old female in our group here. She had a cholesterol level of 183. So if we look over here, it appears that this is her, right? Right there. So it looks like she's got a lower cholesterol than we would have predicted. Good for her. That means she's probably a runner. She's probably healthy. Okay? So the question is, we could do a 95% confidence interval about this line. It'd be interesting to see if she was within that 95% confidence interval. Okay? So we would expect, so as we look at these, okay, so here's your formula. So we're going to talk a little bit about the confidence interval versus the prediction interval. Now the prediction interval, is always bigger. And the reason why it's always bigger is because we have to put a 1 in there. Okay? So let's go ahead and we're going to do this. Okay? I'm going to go back over here to the hypothesis test on the slope here. Okay? So this was the confidence interval for the slope. And what we want to do is we want to do a confidence interval for a 42-year-old female. Okay? Now, in order to do that, we've got to figure out a bunch of this stuff here. The first thing we have to do is we have to figure out our y hat. Then we need to figure out our t sub alpha over 2. Oh, actually, we did already. I'm just going to copy that and paste it. Okay. I'll do that and paste it. Okay, we'll use the same thing we did there. We need to figure out our S sub e, which we already figured out. Except for whatever. S sub e is that number there. Okay? Then we need to figure out our n. We also need to figure our n minus 2. N was 14, I think. N minus 2 is 12. We need to figure out our x star. Here, I'll put it that way. X star, in this case, she's 42 years old. X bar, and then we need the sum of xi minus x bar squared. Okay? Which I believe is this value right here. Okay? So we need to figure out our y hat. Now I pointed to it here. You can figure out what would that value be. I mean, you can guess, but we can figure out exactly what that value should be for a 42-year-old female. How would we figure that out? I'm going to copy that. Plug it into that formula that I just highlighted. Okay? I'm going to bring that over here. Okay, so we're going to take, she's 42 years old times 1.3991 plus 1.35. So we would have predicted that her cholesterol was 210. She was only 183, right? She was pretty healthy. All right, we've got the rest of these here. The last thing I need is my x bar. How do I find that?
Just the average of the ages.
The average of all of these. Here's the guys. Okay, so, oh, she's about the average age, so anyway, she's really close. Okay? All right, so we're going to plug this in. We're going to do the same thing. I'm going to do my lower, I'm going to do my upper. Okay, in this case, the lower is y hat minus t sub alpha over 2 times s sub e square root of 1 divided by n plus x star, she's 42, minus x bar squared divided by the sum, which is right here. There's my parenthesis. Okay, so we would have predicted on the low end she would have been 198. On the upper end, all we do is we change that minus to a plus. So we would be 95% confident that a 42-year-old female should be between 198 and 221. Now that's the mean that I'm talking about. Is she within there? That's good news for her, right? Now, so is she abnormally low? Okay, so this relates kind of a little bit back to the central limit theorem. Remember, with the central limit theorem, if this is the population, and this is your x bar, you're going to have a lot smaller variance for your x bar than you are going to have for your mu, right? So the prediction interval is exactly the same formula. So this was the confidence interval. This is the prediction interval, okay? The nice thing about this is I'm just going to copy that same formula right there, except for I'm going to put a 1 plus, okay? And I'm going to copy that one, and I'm going to paste that, I'm going to change that minus to a plus, okay? So now the prediction interval is a lot bigger, as you can see. Is she within the prediction interval? Yeah. So we're 95% confident that we can predict that the mean age, no, the mean cholesterol of a 42-year-old woman would be 166 to 254. So she's within that. She's within the prediction interval because there's going to be more variation in the population than there is going to be in the mean. Does that make sense? Would you guys like to figure it out for your age? How old are you, Katie?
20.
20? So you're below. Is that a good idea to predict based on the data here? It's not, is it? Okay? Because she's outside here, but she's not that far outside, right? If we were doing a 12-year-old, would that be a really bad idea? Probably a really bad idea. Okay? But should we do Katie? Would you like to do Katie? Would you like to come up and do this for yourself?
No.
Would you like to ace the test?
Yes, I'd like to.
Then you should come up. Okay, so basically, here's the thing. We're going to do this one for 20-year-old. I'll put y/O Katie. You're going to predict your cholesterol level based on this data, which may or may not be any good. This.
Can we decide to reject or do not reject the rule based on the
So, what's the null? So, I mean, you don't always have with a confidence interval, so a null doesn't really apply on this case. I mean, you could go back to the slope here, and you could say, is the slope significant? And you would say in this case, is the slope significantly different from 0? Okay. Now, and so this kind of goes a little bit back to what I was saying before about the last test. Would we expect Katie or anybody else's cholesterol to be 0? Okay. So it doesn't. So we wouldn't want to say that. I mean, you could say it's significantly different from 0, but that's kind of silly, right? You don't expect her to have no cholesterol. She'd probably be dead in that case, right? I mean, you want to have low cholesterol, but you don't want to have no cholesterol. Okay? So, yeah, that doesn't really apply in this case. We would just say that a 42-year-old female, the mean of a 42-year-old female would be between 198 and 221. We would predict that individuals would be between 166 and 254 with 95% confidence.
That's the difference the confidence interval means.
Yeah, this is the mean, this is the individuals. Okay? All right, Katie, knock it out of the park.
Oh no. I was taking notes, so I'll see if I can remember.
Okay, well, Josh, you gotta help her with her notes.
Yeah.
Yeah,
Okay.
do the thing.
So let's figure out your Y hat.
Alright.
Do the thing.
All
with the
those
math.
other things are gonna be the same, right? So let's just pick out a different thing. So what would we predict?
So you want me
Your-
to do my white hat?
Yeah,
Okay.
you're doing the Y hat. What would you predict your thing should be? Anybody wanna guess before she types it in?
Something
my
with
age
numbers.
Okay, but you're typing that in wrong. Because remember, in the times there, it's not gonna automatically go, oh, parentheses,
I need to do equals.
yeah. And then equals, that would help too.
Yeah.
So I'm guessing she's probably gonna be about 160. 179, that was low. Okay? So we would predict a 20-year-old female would have a thing of about there. So all those are gonna be the same. What's gonna be different? Nothing else. Okay?
Moving on.
So I wouldn't even do that. That's the only different thing that she needs to calculate based on her age. Yes.
Wouldn't the X star be different?
X star will be different. Yeah, you're right. So there's two different things. So your Y hat will be different and your X star will be different. Right there. Sorry, am I on the right line? Yes, I am. What's the X star going to be in this case? 20, because she's 20.
Would your X bar be different too?
Would your X bar be different?
Yeah.
No. X bar is still 40. The 42-year-old is the average age.
But if you add a 20-year-old in there?
Well, your equation's going to change, but I'm still going to put X bar there, 42, and I'm going to put 20 here. So yeah, that'll change pretty dramatically. Right.
Do we actually need to add -2?
No, you don't. I thought you did, but you don't. Good thing to add. Okay, so take it away. Do your confidence interval for the average 20-year-old.
Alright.
How many 20-year-olds do we have in this class? Okay, so this is your average too.
That was that big one from you. Can I just copy it over? And then put
You
it
could, well, I guess you could if you knew what you're doing.
If you knew what you're doing. Savage Rick.
How do you paste it on here?
Escape.
I'm so lost.
Escape.
Said I should buy you
Now
dinner
click it where you
first,
want it
but,
to
you
go.
know.
Paste. Control V. Now, what do you got to change? So that's why I think it was easier just to do it from scratch.
Yeah, I don't want to.
Okay, we're out of time.
Sorry.
You know what you're doing?
Yeah, I think so.
Okay, I hope so.
Figure it out.
Okay, this is already posted up on there. 14.2 worked out.